Sampling falls under the data collection step in the statistical investigation process. To find information out about a large number of people, it's generally not possible to ask everybody to complete a survey. So instead, a sample of the population is chosen and surveyed. It's hoped that the information given by this smaller group is representative of the larger group of people. Choosing the right sample size and obtaining a representative sample are harder than many people realise. In this video, we'll look at sampling methods including simple random sampling, systematic sampling, and stratified sampling. The action or process of selecting members from a population for analysis to form judgments about the entire population is called sampling. The features of a good sample are listed here, and I went through them in more detail in my video on data collection. Please watch that video if you need further information on any of these. The accuracy of a sample conclusions can be affected by all of these things. The better they are planned for, the less likely they are to cause misleading conclusions. The best way to avoid bias when selecting a sample is to make sure that the sample is randomly selected. In this video, we'll look at 3 random sampling methods where every unit in the population or everything in the population has the same probability of being selected. The 3 methods we'll consider are simple random sampling, systematic sampling, and stratified sampling. Simple random sampling is a basic sampling technique where a sample is selected from the population at random. Each member of the sample is chosen entirely by chance, and each member of the population has an equal probability or chance of selection. When the population is small, you might be able to draw names from a hat or draw straws. Or the most common method is to assign a number to each member of the population and use a random number generator to pick the sample. And we'll look at a couple of ways to do that now. So many calculators or computer programs have a random number generator. Here I have some graphics calculators. Which calculator you'll use will be depending on your context. You might want to use Excel. In this video, I'll generally be talking about Casio calculators because they're the ones I'm most familiar with. Some of the more common graphics calculators are displayed here. Over the last 15 years, the calculators have changed. The look of the calculators has changed a lot, but the programs haven't changed that much. So if you have an older calculator, then I wouldn't be too worried because it will have similar features. So let's look at random number generating using the Casio FX9860G emulator that I have on my computer. So we enter the run mode, so you press number 1 on the calculator, and then you press Option, and then you press F6, which is the right arrow on the screen, and then you press F3 for probability, and then you press F4 for random number. You can see these on the screens that I've have screenshots of. And then you press execute. And that ran hashtag gives us a random decimal number. What we can do is we can create a formula to turn that into an integer. So in order to turn this into an integer less than 160, we'd multiply our decimal by 160 and use the integer function, or int, in front of it. So I've shown you how to do that here. So we put the ran hashtag times 160, and that's going to give us a number less than 160, or between 0 and 160. And then we use the integer function to remove the decimal points. And that will give us a number anywhere between 0 and 160. And we can use that as a random number generator. So the newer calculators allow you to select integers at a certain interval. Let's have a look at that. Here I have the Casio FX9860G+. This has a ran int number function where we can enter the first number and the highest number, so 1 to 30, and we in this case we will enter 3 to say we want to select 3 numbers. We might have allocated a number from 1 to 30 to all of the students in a class, We want to pick 3 of them at random. And what we do is we put this into a calculator and it will give us 3 numbers at random, and those are the students that we would use in our sample. Another way we can do this is with Microsoft Excel. It has similar functionality. So you can either use equals rand, and I've shown you 10 examples here where it just produces decimal points, similar to the calculator did in the previous example. You can modify that slightly to turn it into an integer of between 0 and 10 by timesing by 10 and putting the integer function in front of the random number generator. That looks very similar to the one we looked at on the last slide. And now again, if we times it by 160, we're going to get random numbers generated between 0 and 160. So on the third column C in the Excel screenshot, I've got equals int, which stands for integer, open bracket, ran with open close bracket. That will give us a random number, times 160 gives out a random number between 0 and 160, and we close bracket, and the integer function just removes the decimal points. Let's have a look at systematic sampling. In systematic sampling, the population is arranged into an ordered list and the members are selected at regular intervals through that ordered list. A random start is used and then proceeds with the selection of every kth element from then onwards. In this case, k equals the population sample size. So let's have a quick look at this. It's important that the starting point is not the first person in the list, but is instead randomly chosen from within the first to the kth element in the list. A simple example would be to select every third name from the telephone directory. And every third sample, also referred to as sampling with a skip of 3. So you can see here I've got a diagram of a man, and we've picked every third man. So you just count along the ordered data. You go 1, 2, 3, 1, 2, 3, and you pick that member of your population. And that's how you pick the sample. So let's look at an example of systematic sampling. Imagine you would like to sample 10% of students at your school. We can write 10% as a fraction, as 10 over 100. And we simplify that to 1 on 10. Therefore, 1 in 10 students need to be surveyed. So we order the student IDs of students and randomly select 1 from the first 10. Then select every 10th ID after that. So here I've ordered 40 student IDs, randomly selected the 8th student ID in the first 10, and then I select every 10 after that. So you can see I've got them in groups of 10 to make it nice and easy. We selected the first student ID was a 108, then we select every 10th after that. So we go 108, 118, 127, 138. So systematic sampling is useful when not all the members of the population are available for sampling at one time. Suppose a large department store wants to obtain customer service feedback. The store decides that 4% of customers will be sufficient. So 4% as a fraction is 4 on 10, which simplifies to 1 on 25. Therefore, 1 in 25 customers needs to be surveyed. And what the department store would do is select a customer at random from the first 25 for the day. Then they survey every 25 after that. So let's look at stratified sampling. When the population has distinct categories or subgroups, the population can be organized into categories or subgroups. Each category or subgroup is sampled independently, and individual members are randomly selected from the subgroups. Every member of a subgroup has the same chance of being selected. Selecting the same number of members from each subgroup ensures a proportionate representation in the sample. Adequate representation of minority subgroups can be ensured by stratification and varying the percentage of the sample that come from each of the subgroups. Since each subgroup is treated as an independent population. Different sampling approaches can be taken for different subgroups as required. So when sampling gender groups, you're drawing a sample from each gender. So drawing a sample from each subgroup. Here we have a group of 8 people, 4 women, 4 men. We might say that we want to sample 3 of the women, 3 of the men. Therefore, we select 3 women and 3 men. Another example might be sampling across year levels at a school. You might not want to take all of your sample from one year level, so you'd select a sample from each year level at that school. So in summary, we've looked at what sampling is in this video. We've looked at the sampling methods: simple random sampling, systematic sampling, and stratified sampling. Thank you.